Okay, and ask questions because I actually felt the file system is sort of like it's a magnificent pieces of ideas put together for creating a file system. So ask questions as usual, I encourage you. And let's start our journey for this last piece of the puzzle for operating system. So this is all about file system, and the goal of file system is essentially that how should the operating system efficiently manage a persistent device. So just imagine this situation, extremely practical one. You just bought a hard drive or a SSD from the shop, and your operating system now needs to make use of that persistent storage device. What does it mean by persistent? Means that between reboots, even when you power off your computer, the data stored in these devices will stay there, even without power, and you can retrieve them. This is in opposition to RAM, where if you switch off the computer, the contents of RAM typically goes away. So this file system chapter or this part is all about how when the user gives the operating system a hard drive or an SSD, how do the operating system utilize it, that storage space efficiently. And efficiently is the key here. So by efficiently, what do I mean? Efficiently, I mean these three different dimensions. What would be the data read or write abstractions that is provided in the hard drive by operating system? What do you mean abstraction? Meaning that you cannot say that write, I mean, just think about it. I mean, if you, instead of saying printf or basically fwrite or this kind of calls, say you have to write in this particular memory address from block X to block Y using this function calls. The second one doesn't even make sense to most of us. So what are the best read or write abstractions? Very easy to understand. Even a school kid can do it kind of way. What would the operating system should give us? The second question is that, okay, the operating system give us some abstraction of reading and writing data on disk. How do we use those abstractions? You need some APIs, application programmer interfaces. What are the APIs that are needed? And finally, how to implement those APIs efficiently? These are three questions that we will talk about. The very first question, and I believe the one of the most important one, is what are the data read or write abstractions? So the operating system started with just a bunch of um, blocks. So basically, the operating system started with a disk, and the user does not know disk, does not know anything. It just wants to read or write some data um, in the disk. So let's start at the beginning. How does the structure works? Let's take a top-down approach. So in the beginning, you just have a disk. You means the operating system developer, you just have a disk. And consequently, what people did, the operating system developers, and you would learn in this course, in this part of the course, is what are the data structure that the operating system developers create in the hard drive. So let's look into the structure, the data structures, everything like a whole ecosystem that is created in your hard drive. So the operating system, when you are viewing, when you as a developer, operating system developer, would view a hard drive, how would you view it? It's essentially a big array. Okay, that's the best abstraction, most common abstraction that OS has primarily when it interfaces with the hardware. Like if you have a storage device and or peripheral like your USB drive, your camera, or anything, you can bet $10 that your operating system, when it talks to the hard drive, read and write data to the hardware, actually, not only hard drive, but also your camera and your speaker, it always sees the hardware as a set of blocks that can be accessed using memory addresses. Of course, this is a logical view. Your speaker is very different than your hard drive, but as operating system, you assume that there are a set of logical blocks which you read or write. Now, for operating system, that might work, but for user, that will not. For example, if you buy, say, 5 hard drives, and there are slots in your cabinet or slots in your laptop, how would the operating system structure or arrange those hard drives? Because this is only one user, and even if you have, say, bought 5 hard drives, each 100 GB, you have 500 GB space. You have some way to access those 500 GB as one user. So here is the way operating system created an order within chaos. You take or all the sets of hard drives in a computer. These hard drives or SSDs or in general disks, they can be subdivided into something called partitions, which is the logical view. So what are the partitions? Essentially, it is a bunch of logical blocks, memory blocks. Think of a big array. C array, that array. Now, these partitions can be used either as raw, like if you go to your partition manager in Windows, or you have equivalent functionalities in Linux and Mac also, then you would see that partition can be used as you create a new partition, format it, it can be used as raw, that is without a file system, or it can be formatted. What does format mean? Means the operating system will create a file system structure, which we will learn in this course. But it will create a file system structure in the partition. Partitions are also called mini disks and slices. Not very important, but you should remember this because sometimes, even specifically in the cloud computing lingo, you have slices. This slices of a machine or a storage space. So slices are nothing but a partition. So one partition essentially means either a set of blocks without a file system, that is a raw partition, or it is formatted with a single file system. And when the partition is formatted with a file system, it's called a volume. Let me give you a pictorial description and then let's actually take some questions, like if you have any doubts. What does it mean? Like, let's take a pictorial view. So imagine that you have one hard drive, say it's a 128 GB hard drive. Okay? So logically, the operating system can divide it into 2 partitions if you need, or 3 partitions, or nth number of partitions, the same hard drive. You can have, say, 2 partitions 64 GB each, or 3 partitions 40 GB, 40 GB, and 68 GB, anything that you want. You means as the user. You can say create a partition of this size. The operating system will take 40 GB blocks and create this structure in the same disk for a particular partition. So what does it mean to be a partition? It means that you have a single file system. What does a file system mean? It means it has a directory and a bunch of files. For example, in partition B, you have a directory and a bunch of files, and in partition B, you have a separate directory and a bunch of files. Remember that partition A and partition B resides in the same disk, no differences. So one hard drive can have 2 or 3 or 1, 2, 3, as many partitions. It can also have raw space. without any file system. So on the other hand, like this is in this case, this one is divided into two partitions. On the other hand, it might be that two disks, you took one disk 100 GB, other disk 100 GB, total 200 GB space. And then you can actually create a partition which has the same directory and same set of files, not same set of files, but it has one directory and one set of files spanning both the disks. So one partition can span two disks. Any questions so far about the file system? Like the organization. So you started with a bunch of disks, and then either you divide each disk into multiple partitions, one partition, multiple partitions, or you can combine disks to create partitions. Okay. So questions? If not, I have a question actually. Um, this I actually talked to you about each partition will have one directory and one file, like and the set of files. So what do you think is the functionality of directory and files? Why do you need this structure? Is anyone here? Let's see. Oh, there are a couple of people. So we are talking about this, and essentially, let me switch off. Great. So if you guys are here and you understood, sorry, ask questions if you don't understand. Like we started from the disk and now we are going into the file system to create in these disks. So, and while creating the file system, I actually use terms like directory and files and so on. So this is basically one volume, one partition, directory plus files. So what do you think the functionality of files and directory? Why do you need this abstraction even? I hope that will be clear later, but I just wanted to see that what is your abstraction or what is your mental model of this directory and files. So let's see later. Essentially, each volume essentially contains a device directories, or it's also called a volume table of contents. So what does this table of contents remind you? So directory is called volume table of contents. What does that table of contents, this term, remind you of? Hello. Is anyone available? Please say yes, or I'm not quite sure whether this.
Yes, sir.
Okay. Page table. Table of contents went to page table. Okay. Anyone else? Other than Ashutosh? Where do you see table of contents in offline world? Yes, books. In folders, what do you mean folders, Srijan? Like table of contents in folders, like you mean the like files and folders, like in the office?
Yes, sir. Something like that.
That's true. So in the folders at the beginning, you have a table of contents. You need those things. Okay. Why do you need that? Essentially, let's see what is the requirement of that. Essentially, for a file system is just two things. You need to learn just two things: set of files and a directory structure. The analogy is you can think of your hard drive as a book, okay? Book with empty pages. If I give you a bunch of pages, just empty white pages, and you want to actually put something in it with all possible, something means like you want to create a book, a paper, a chapter, a report. And if you want to do it properly, like a thesis, then you will have the chapters in the book and an index. Why do you need that? Well, the chapters are your actual data that people will read and appreciate. Index is so that they can navigate the book efficiently. So let's actually see that in a file system, because there are only two components, let's go over them one after another. And think simply, again, this systems course, which means that most of the concepts are simple, but they become, but you need to actually consider a lot of corner cases. So let's actually look into each one of them, how set of files and directory structure works. So first, let's start with what is a file? And why do you need a file abstraction? So the reason is that just like if I give you a bunch of white pages, it's extremely hard to say, go to page 13, read third paragraph. Because it is logically or read even worse, go to page number 13 and read 1,000 word. This is extremely cumbersome, right? But rather you want something bigger abstraction, like a chapter, like a subsection, like a concept, like read these 3 pages for section 3.1. So you need that structure, and that is the exact analogy people came up with when in the 80s or 70s they actually start creating modern file systems. So what is a file? File is the read and write abstraction for storage. As a user, you are never going to see a block of addresses on hard drive. What you'd always see is reading or writing to a file. A file is often a set of blocks. Who does the translation from files to blocks? Well, of course, operating system. So what does this abstraction pertain to? This file? The file is essentially a named collection of related information. So forget about related information. All it means is that it's basically a collection of hard drive blocks. The big array that the operating system sees, it gives you a part of this big array and say like, name this name this array indices 231 to 520 as your file. For a user who is using your operating system, the storage abstraction, the file abstraction only means is the smallest allotment of logical logical allotment of secondary storage. So you cannot read or write not memory, sorry, storage blocks, but rather you have to read or write to a file. And this is done so that the users can easily conceptualize or have an abstraction which does not require them to know anything about the storage actual addresses. Now, what are the different things that is included into files? You all have seen files. You are using it from your first year, even earlier, even from schools. right? And now I'm talking about files and folders, not in Office, but rather in your computer. So you can primarily divide the files, or the operating system divide the files into two types. One is data file, second is program file. A data file essentially means it contains data. Data is whatever you wrote there, whatever your program generate, whatever it is essentially data which can be numeric, that is just numbers. It can be character data, that is like you wrote a story on a gedit file, or a file created by gedit, or it can also be binary data. Do you have an example of binary data files that you always use? Can you give me one example of a binary data file that you often use? Have you seen images or videos? Do you ever try to open them or basically read whatever is in that video or image file, like using a cat? You'd see there is only binary data. It's not character, it is not interpretable, it's just bits and bytes written in the file. Okay, so this is the first type of files, which is data file, just for storing data. The second type of files is called program files. What are program files? At the end of the day, it will again be a binary file, however, with some specific control characters so that the binary file can be executed. It is generated by your compiler, and this can be executed because it means the program file will contain executable instructions for your machine. An image file will not. So the program files which can be executed essentially means that contains often binary data which can be interpreted by your operating system and interpreted by your operating system as machine readable codes, and that can be run in your processor. Now, someone needs to actually tell if you're creating a file, you need to tell me when you are sharing that file, or you need to even tell the operating system what type of file that is. And that has been done. That has that power. That is what a file generally does, or generally meant for. That power is bestowed upon to the file's creator. For example, the creator can actually mark something as a text file, like just text data, or a source file, the code that you wrote, and or an object file, or even an executable file. So any idea how would the user define such a type of a file? So think about the user. I mean, what would you as the Waze developer would give them? Like they should have some power, like some way to express that, well, this file is a text file. How would they do that? Have you seen a file name? Like what is a common file name? Srijan, okay, yeah, extension. So a common file name might be a.pdf. So this PDF part is called an extension, and it essentially tells, right? Srijan is absolutely right. It essentially tells what the file type is. Simple stuff. Now, irrespective of the type, or basically depending on the type, the file should have also structure, because you can actually give wrong extensions to file names and so on and so forth. Like you can actually name a.pdf file as a.text. You can. No one is stopping you. Right, Ashutosh. That's where I was getting at. you can have an executable stored as a PDF. And that's where the attacks and everything comes in. So Ashutosh, you are right. I mean, the moment you are giving power to users, some users will abuse it. And let's actually talk about that now. So essentially, it's not only the file type, the extension, but also the file often have a structure that is sequence of characters. For example, a file structure, common file structure that, and these are many times these are hard coded into operating system. So if say operating systems support file types like all operating systems support a file type, which is or file structure, which is none. None means there is just sequence of words or bytes. An operating system will provide you software to read that, like cat, simple. Then it will just paste, put like the words or bytes, interpret and put in your terminal. The second way is have simple record structure provided by the operating system, which means that there are some files which are lines, which are basically like record structure, where each line is one record, or if not each line, like there are multiple records which are separated by multiple control characters like /n. Each record might be one line, it might be fixed length like only 80 characters and then a break like line break, or 80 characters and then a new line, or it can be variable length. The interesting bit is that in most of the general purpose operating system, you are not going to get this record structure and so on. But the operating system that I'm talking about, like think about embedded systems that run your ATM machines or some database servers, they actually use quite a few record structures and lines and fixed length, variable length, and so on. What I'm trying to actually tell you is that, so on Ashutosh's hint, what I want to actually point out is that these some of the operating system themselves can define the file structures. The most common one is just a file is just a sequence of words or bytes, and then leave it at that. But in some specific cases, the operating system themselves like, no, if you have this particular like you can create a particular file, say database record file, which have the following structure, and the operating system will know exactly what to do with the file. These are special purpose operating systems. Now you can actually simulate this complicated, more specific database server structure or some specific embedded system structure by using specially formatted document and by inserting appropriate control characters. What are control characters? Like /n, telling that when the record ends, it actually makes sense to you, or what to do with a particular file, encode that information in a control sequence. Control sequence are sequences which just provides metadata for that particular file. So you might actually ask, what is the use of a control sequence? Like the operating system created a particular file type, and operating system will provide utilities, kernel functions to call the read and write those kind of files and do whatever the kernel provides you to do. The reason we have this simulation of this special type of files using control characters is that this technique is extremely useful for specific programs. If you look into your Adobe Acrobat, or if you look into your Oracle database server, you'd see that they are creating file and file types that no one else can open. So specific softwares today define their specific file structures, and often you can open, read, or write to those files only using those softwares. On the other hand, some file types are used or openable or writable, readable by multiple softwares, like your JPG file, like your PDF file, like your PNG file, text file, and so on. So the file structure, what I want to actually tell is that for a file is essentially your logical unit of reading or writing data to disk, and both operating system or some specific programs provide you some file structure. Now coming back to Ashutosh's question again, because it is sort of like a defining question in this sub part. Essentially, there are these different types of file types. Those are possible, like your name and extension and so on and so forth. Like, you know, if in a file, there are two pieces: file name and file extension. A.pdf, A.exe, B.pdf, assignment.c. And here are these three different types of files and their extensions. Like there are executable files like exe, bin, or others, which are provided by operating system. So the operating system knows that it is ready to run machine language program. So oftentimes, let's actually see that what happens if you name a.pdf as an a.exe. The operating system will try to run it, and it will find that the data contained in that file is not a machine language program. It will abort. Similarly, if there is a PDF like object file, that is object like .o is often the extension for this file. Extension is basically after dot, whatever you have is extension. You can define your own extension also. So object file is the compiled machine language code, but it is not linked by the operating system. Then you have the source codes, like source code in specific languages. You have batch, like the terminal code files like BAT in Windows and sh.sh files in Linux. You have text files, you have Word files, you have library files like shared library files. Remember in memory we talked about shared library files, how they actually used and so on and so forth. You can have like this image files like JPG, PS, PDF. You have archive files, that is for compressing data, or you can have multimedia files also. So these are very common file types, and I guess you don't even need to remember it that much because it is very well known about. I mean, this file types are very well known. Now, what if someone actually name a file wrong? One might be if someone actually name a.pdf at a.exe. And when you click on it, the operating system will try to run that a.exe, find it's not a machine readable, machine runnable code, it will abort. What if someone actually put a.pdf at a.exe? A.exe at a.pdf, where a.exe is a malicious file. What will happen then? And someone double clicked on it. Any idea? Ashutosh, what do you think will happen in today's operating system, like in Linux? Yes, the question is that if you have a.exe file, you name it a.pdf because it's on you, like the user, you can rename it. You rename it to a.pdf. Then you someone else double clicked on the file. What would happen if someone wants to read to the from the file? Ashutosh thinks that it will execute. What do others think? Because name and extension, I mean, based on whatever we talked so far, that sounds like a reasonable outcome. That is, it is a.exe, so it's essentially, sorry, it's called a.pdf and it's actually an exe file, so it will start running. What do others think? If you rename a.exe to a.pdf, double click on a.pdf, what will happen? Will it execute? Yep. So Parth actually wrote, according to Parth, the default PDF viewer software will try to run the file and hopefully fail. That is exactly the expected behavior in today's operating system. So essentially, the operating system has this default values for or default softwares for different file types. Okay, very important. And essentially, the default PDF viewer, say your Adobe Acrobat or Evans or whatever the operating system gives you, or you installed and changed the default in the operating system, they would try to run that a.pdf and they will fail because it is actually a.exe and it does not follow the file structure expected by the PDF file. So file names and extension give users power over files and tell that what softwares to run, what software used to run it, or what the file represents. Some people might abuse it, but hopefully in most of the cases, those abuse just result in aborting reading or writing to the file, nothing more. Now coming back to the benign domain, where you have only a file name and extension, let's see that what else the operating system stores with a file. Then file name and extension is only for you as the user. Okay, user can change it also and do some funny things. But the operating system stores a lot more because they need to arrange and organize the files in hard drive. So what are attributes? What are those attributes that operating system stores with the files? The first one is the name. That is the name that you have given to the file. The second one is identifier, which is the unique number that the operating system gives to the file. Operating system does not know, it doesn't really know assignment 1.c. It only needs 0, file 1, file 2, file 3. So this unique number identifies uniquely that file to operating system. The third one the operating system stores is the type. And based on the type of the file, which is given by extension, the operating system basically attaches default softwares to run that file. The fourth one is a location, that is a pointer to the actual file location on the device. That is, your device essentially means our hard disks. It also contains, because you have the, so at the because the operating system stores the location, it has a pointer to the actual memory pointer to the actual storage blocks on device. And not only that, it also have the size of the file. It has, operating system also stores three more things. One is the protection bit, that is who can access a file, because in a multi-user system, it is important to know who can access a particular file, and others who do not have access to it should not be able to read or write to that file. That means those storage blocks. So the operating system stores who can read or write to a file, those permissions. Then operating system stores when the file, the time and date of different events associated with the file. When was the file created? When was the file last modified? When essentially which user created the file? So this data is this time and the date and user identification is often used by enforcing protection, security, and try to find usage like when the file was last changed. Sometimes in some operating systems, specifically think more fault tolerant storage devices, okay, operating system also stores extra information like checksum And what is checksum? Checksum essentially gives you a way to know if a file is corrupted. If someone changed the storage blocks associated with a file and wrote random data. This is needed for a property called integrity of file system. I don't know if did any of you actually check CRC error, say while extracting a zip file? Checksum error. If not, you are lucky. But if you did, you'd know that some operating system actually need to store those checksum for detecting changes in files. Quite often, due to system failure, files change or files got corrupted. Random data is written on those storage blocks, and someone needs to identify that that kind of problems have happened. Now, where was this? All these attributes, name, identifier, type, when the file was changed, and all these things were stored. Essentially, this is stored in the directory structure. Your directory structure, your files are just blocks of storage devices, nothing more, nothing less. All this information, rest of the information is stored, which is also called, this information is also called attributes or metadata. This is stored in your directory structure. And where is the directory structure stored? Remember this picture before, which is like directory structure resides at the beginning of a partition, the hard drive itself. So how do you actually know the information? So you, as from the user space, definitely have permission to look into this metadata for a file which is stored in the directory structure. And here is an example. Essentially, you can use multiple commands to know about it. Like I put 3 comments here. One is stat, which is short for statistics. So if you give stat and the file name, in this case notes.txt, you would see this output like file notes.txt. What is the size? 39. The blocks, number of storage blocks on your hard drive, 2. The device is, this is the inode, this is a number, like the unique number that the operating system knows, 64392. This is the name that I use, notes.txt. This is the name that operating system use. Then it has who created this file, and essentially the group of that user, like in this case, Mina created this file, and the group is NS Science. We'll talk about groups in a while. But essentially, these actually tells this access, modify, change. This tells when the file was modified and who can modify the file. It also have exactly where in the device the data is. In this case, 5DH by 93D, which are codes for internal representation of the device to operating system. So for files, file is nothing but a bunch of storage blocks in memory associated with some metadata, and that metadata is stored in your directory. So remember that, I think you guys have appreciated so far that how important is directory. The file itself is essentially a chapter in a book, but without an index, you cannot really get that chapter. You won't really know who wrote that chapter, what is the speciality of the chapter, or even a summary. Some indices also consider that. So far, we talked about then the files. What are files, and what metadata is associated with files. Now let's talk about what is a directory. Before we jump into that, any questions about the files and the extensions and so on? What is the difference between modify and change? So this is very specific to this Linux version. Essentially, essentially what happens is that for the file system stores that when the file is updated, like the specific, like say the file protection is updated or file access is updated, so different metadata is updated, it will be called the file is modified, and like the for change other metadata is updated. Like for example, if I recall correctly, I have to check again. However, if I recall correctly, for changing, you actually know the storage blocks have changed. And access essentially means that it is only read. Change means it is written. On the other hand, modify essentially means that other metadata is modified, like even the time to access or the protection bits or the access bits. So it is modify and change actually depends on whether you are changing the storage blocks, the data, the chapter content of files, or you are changing the index. But it has different meanings in different operating system. I know at least for one, I think one version of Debian, that was the interpretation. Any other question? Okay. If none, then so far, if you are creating a book out of your storage device, you know how to create the chapters. Now let's see how to create the index. Because chapters, creating the chapters only means that you know how to read and write data there and associate some metadata with those storage blocks, with the files. But how to create the index? Because without index, you cannot really find those chapters. So what is a directory structure for files? Essentially, a directory structure, this is a simple pictorial diagram, very simple. It's essentially collection of nodes containing information about files. So there are files like F1, F2, F3, F4, F dot 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 Fn. There are n files. For each one of them, you have a set of nodes containing the metadata, and the collection of those set of nodes together, it's called a directory. You can think of very basically what is a directory. It's a data structure of a bunch of structs. Each struct will point to some storage blocks. And the struct will also contain some metadata about each storage block. Remember that both the directory structure and the files reside on disk. Right? So this set of structs, the directory, will reside on the disk, and they will point to other portions on disk which contain the actual data of the files. Now, this directory structure is extremely useful simply because the first time you as a user ask like open assignment 5.c. Your operating system will first go to the directory and find out where is that assignment 5.c. It ultimately knows the positions of the storage blocks and read from there. So without directory, there is no way operating system will know which parts of storage blocks they need to access. So creation of directory is something that we will actually continue, and we will talk about it in the next class. Like we'll talk about how to actually, what are the algorithms and so on and so forth, creating better directories and so on. However, let me just give you one simple idea that in this directory design, like designing the directories and the algorithms that we will learn in the next class, we have to consider a specific system model. And that system model essentially is there are multiple users in a single machine, and each user might need a bunch of files, like you and your friend and your other friend. All three groups are working on department server to do the final assignment. Each of your assignment name is assignment 5.c. So in your system model, each of you needs to create a bunch of files independently. Your access of your assignment 5.c should not affect others. And there is also another last assumption is that your group, like your group, the other group, the other group, all of them acting independently. You cannot really depend on any of the actions for creating the directory or accessing the directory. So this is the system model that will work, a multi-user environment where each user is acting independently and they need a bunch of files to do their task. We'll start from the next class on what are the requirements of such a directory, because whenever you want to solve an algorithmic problem, at least in this Wells case and so on, first you need to write down that what are the requirements of an efficient data structure, and then you will start use all the things that you learned in algorithms and all these things to actually create data structures to which satisfy those requirements. So we will start from next day. Under this design, multiple users and they want a bunch of files and so on. Under this system model, what are the requirements for a good directory structure? Any questions? Okay. Um, any questions regarding the file structure? So far, what we talked about and the directory structure that we just started. If none, let's actually wait for a minute. If you have any questions, please ask. Okay, then. If there are no more questions, then let me stop the recording.